Now we come to the second type of disaccharide that we have, and that is maltose. So maltose is a disaccharide. Disaccharide meaning that on hydrolysis, it will yield us two monosaccharide units. So maltose comes under the category of disaccharides, and it is made up of two monomeric units. Now, two monomeric units, what are they? So both of them are alpha D glucose. So we'll be writing alpha D glucose here also, as well as at this place. So two monomers which are actually the same. And how do we write alpha D glucose? Alpha, when there is alpha, then our OH position is cis. So both of them, the OH lie at the same side, and on the second one also, we have them lying at cis. Now, so we have got two monomeric units, which is alpha D glucopyranose, we can call it, and thus the monomeric unit. Let us just write it here since we are going to write the main points of highlight. So, monomeric units are nothing but alpha D glucopyranose over here. Now, coming to the next part that we want to see in this particular maltose is the presence of anomeric carbon. So, anomeric carbon is present over here as well as here. So, at C1, on both of them, on both of the alpha D glucose, because they are the same, we can see at C1 we have the anomeric carbon. So now if we want to form the maltose unit combining these alpha D glucose, what are we going to get? So the anomeric carbon is over here, and what happens is that from these two carbons, we'll be losing an H from here and an OH from here, and we'll be getting an ether linkage similar to as in our previous sucrose. So here we have an ether linkage, and we can clearly see that this is formed by the loss of a water molecule. So the rest of the carbon remains the same. So now you can clearly see that we have talked about the presence of anomeric carbon and how they are helping us in telling about the sugars, whether they are reducing or non-reducing sugars. The presence of anomeric carbon highlight the fact that the carbohydrates will give a Felling and test and the tolerance test, and both these tests will be positive. So any absence of these anomeric carbon, as in the case of sucrose we have seen, will result in the reducing sugars turning into non-reducing because of the loss of this particular group, that is the aldehyde group. Now, let us just see what happened to the anomeric carbons now. So, the anomeric carbon was here and here. So, now I can clearly see that what are we seeing? That in one unit, that is this particular unit over here on the left, this unit over here, this is actually non reducing. So, if I see this unit, it is actually non reducing. But when we come to this right side unit, that is this particular unit, the anomeric carbon over here is remaining untouched by this ether linkage. So this is in fact reducing. So overall, this whole maltose will be a reducing sugar. So let's just first write the name. So this is a maltose unit. And a fact which is very, very clear to us is that if suppose we take a water molecule over here, what happens is we can easily see that the loss of water from this particular, both of the alpha D glucose resulted in maltose, because when we bring a water molecule, if this H connects to this OH and this OH goes back, we get the same 2 alpha D glucose unit that we used in the first position. Now, we have now seen the that the anomeric carbon, coming back to the anomeric carbon, let us just see here in this maltose, in this particular maltose, one anomeric carbon, that is this anomeric carbon, is remaining untouched. Now, since the anomeric carbon is not destroyed in this particular unit of maltose, so this maltose is actually giving both the Tollin and the Pelling test and will be a reducing sugar. So we can just write that maltose gives positive test for for Pelling and Tollin's reagent. So we can clearly see that maltose over here will be a reducing sugar. Now, this point is covered. So the two monomeric units are of alpha D glucopyranose, and since we have anomeric carbon present in the maltose unit also, it is a reducing sugar. Also, we know that this particular linkage over here is known as the glycosidic linkage. And now in this particular maltose, if we see the glycosidic linkage, we can see that this particular glycosidic linkage is existing between the first, see this is the first carbon, the second, the third, respectively the fourth and the fifth. Now, if we look at the second unit of alpha D glucose that we used, the first actually lies here, the anomeric carbon, of course, second, third, fourth, and the fifth. So we can see that we are actually using C1 of one unit of alpha D glucose and C4 of another unit of alpha D glucose. So we can just write over here that the glycosidic linkage is between it is between nothing but C1 and C4. Okay. Also, so we have seen that disaccharide maltose, it is composed of two alpha D glucose unit in one, in which C1 of one glucose is linked to C4 of another glucose unit. Okay. Now, and the free aldehyde group can be produced as C1 of second glucose in solution, as it shows reducing properties. So it is a reducing sugar. Now, we have covered all the few things that we wanted to see about maltose. So now, what were the main highlights? That it is firstly a disaccharide, then it is made up of alpha D glucopyranose, that is 2 units. It is a reducing sugar. Also, the glycosidic linkage between C1 and C4. So here we can see this is a very good example of disaccharide which on hydrolysis yield two molecules of the same monosaccharide. In the previous case, that is the sucrose, we saw that disaccharide units were yielding two molecules of different monosaccharides. Here they will yield 2 units of the same monosaccharide. Now, here we saw that glycosidic linkage was existing between C1 and C4, but in the previous case, that is the case of sucrose, we saw that the glycosidic linkage will actually be between C1 and C1. So this was actually the glycosidic linkage. Okay. So glycosidic linkage is nothing but between C1 and C1 of C1 of alpha D glucopyranose and C1 of beta D fructofuranose. So this one point we have to keep in mind over here about the existence of glycosidic linkage in both these two, sucrose and maltose.